This is problem 30 from section 4.4. It is similar to problem number 4 on the homework. So if you can follow along with this, you should be able to do the problem that's on the homework. In your text, it says, use the quotient remainder theorem with d equal to 3 to prove that the product of any two consecutive integers has the form 3k or 3k plus 2 for some integer k. After writing this with the English sentence, I have rewritten it symbolically. It says for every integer n, the product of n and the next integer, that's the consecutive one after it, has the form 3k or 3k plus 2 for some k that's an integer. And we've already said we're going to use d equal to 3 and use the quotient remainder theorem. When we do this, we can see that n can have three forms. N can be 3 times a quotient, or the second thing is n could be 3 times a quotient with a remainder of 1. Or the third choice is n could be equal to 3 times the quotient plus a remainder of 2. Let's look at all three of these cases. In case 1, when n is equal to 3q, n times n plus 1 is going to be 3q times 3q plus 1. If we multiply this out, we get 9q squared plus 3q, and we can see that we have a factor of 3 in common with these two terms. So here we have 3 times 3q squared plus q. If we then let our k equal the expression that's in the parentheses, the 3q squared plus q, then we can see this is of the form 3k, and it fits in with the first form of the 3. Now let's look at the second case. In the second case, n is equal to 3 times some q with a remainder of 1, or plus 1. So now n times n plus 1 is going to equal 3q plus 1 times 3q plus 2. When we multiply this out using FOIL, this times this, FOIL is first, outer, inner, last, this times this would be 9q squared. This term times this term would be 6q. This term times this term is 3q, and 1 times 2 is the 2. We can combine the like terms of 6q and 3q. 6, 7, 8, 9 makes it 9q plus 2, and the first two terms have, again, a common factor of 3. It's going to be 3 times 3q squared plus 3q, and then we have plus 2. In this case, if we let k equal to what's in the parentheses, the 3q squared plus the 3q, we get that this is equal to 3k plus 2, which is of the second form. When we do the third case, we're going to let n equal to 3q plus 2. So n times n plus 1 is going to be 3q plus 2 times 3q plus 3. Again, using FOIL to find this product, this term times this term is going to be 9q squared. This term times this term is 9q. This term times this term is 6q, and this term times this term is 6. Again, combining the like terms, 9 plus 6 is 15, so we have 15q plus 6. And again, we have a common factor of 3. 3 is going to be multiplied by 3q squared to get the next first term, by 5q to get the 15, and by 2 for this one. Again, if we let k equal the expression that is in the parentheses, k is equal to 3q squared plus 5q plus 2, and you can see this has the form of 3 times k. We've done all 3 cases, so we're done. You can end with a little box, or you could be the old-fashioned way and say QED, and we are done.